let's just look at, the first one is going to be asking, and I'm going to do problem 2. So I'm going to be doing problem 2 on page 22. And we need to look at this echelon, because the instructions are saying, determine which matrices are in reduced echelon form and which others are only in echelon form. And you go back and look at that definition on page 13. And echelon form, it meets the first 3, and reduced is 4 and 5, right? So echelon form, it says all 0 rows are above any rows of all non-zero rows are above rows of all zeros. So let's look at 2A. So the non-zero rows are above rows of all zeros. We have one row that's all zeros, right? And every other non-zero row is above that. Things that have non-zeros. So it meets that criteria. So it could be echelon only or reduced echelon. Both of them require that. Now the next thing says each leading entry of a row is in a column to the right of the leading entry of the row above it. So if you notice row 1, we have a 1 there in that upper left hand corner. Row 2, the first element is to the right of a leading term in the row above. So it meets that, correct? So we're still good on both echelon and reduced echelon. It says all entries in a, I'm looking at number 3 back on that 13. All entries in a column below a leading entry are zeros. So the first row's leading entry is the 1 in the far left upper corner, and there's all zeros below it. The second row's leading entry is the 1 in the third column, and it's all zeros below it. The third row does not have a leading entry, so it meets that criteria, correct? So echelon form, right? That is in echelon form. Now to check and see whether it's in reduced echelon form, it says the leading entry in each non-zero row is 1. So the non-zero row is the third row. The next one up, the leading entry in that row is 1, and the leading entry in the top row is 1. So it meets that much of the reduced echelon form. Then it says, number 5, each leading one is the only non-zero entry in its column. And so the top row, that one is the only non-zero entry in its column. The next leading entry in row 2 is column 3, and that's the only non-zero entry in its row. Now, column 4, we don't worry about it. So what is that? A? Reduced, it's in reduced form, right? So A is reduced echelon form. So let's look at B. All zero rows are above rows of all zeros. Does B meet the first criteria? I'd say yes, wouldn't it? All non-zero rows are above rows of all zeros. Number 2, each leading entry of a row is in a column to the right of the leading entry of the row above it. Well, the leading entry, that's right, because the leading entry on the first row is the top, the top leftmost. Then the next one is the next column over, right? And then the next one's the next column. So it meets that much of the echelon form. Number 3, all entries in a column below a leading entry are zeros. That's good, isn't it? So far it's an echelon form. Now it says to get reduced. The leading entry in each non-zero row is 1. Okay, that's true, right? So part of the way to reduced. And then it says each leading one is the only non-zero entry in its column. How about that one? No, it's only an echelon form, right? Okay. Okay, number C, it says A, all non-zero rows are above any rows of all zeros. All non-zero rows are above any rows of all zeros. What about that? Looks to me like it fails it, don't it? Because row 2 and row 1, non-zero row in row 1 is the top left-hand corner, right? And it doesn't have a 0 under it. So it's not an echelon form. As you see, it says all non-zero rows are above any rows of all zeros. You agree? So it's neither, right? I mean, see what it is, it's trying to say, is it ready to solve for equation, solutions? And that one wouldn't be ready. Okay, then D. All non-zero rows are above any rows of all zeros. Looks to me like that's okay, isn't it? It says each leading entry of a row is in a column to the right of the leading entry of the row above it. Well, that works, don't it? Number 3, all entries in a column below a leading entry are zeros. Notice the leading entry in row 1 is in that column 2, row 2 is in column 3, and row 3 is over there in that column. What is it? 5. So it looks like it might be an echelon form, right? Reduced. It says the leading entry in each non-zero row is 1. It's not that, right? Second row's leading entry is a 2. So it's echelon, but anyway. good with that? Everyone good with that one? Now the next set says, row reduce the matrices in exercise 3 and 4 to reduced echelon form. Circle the pivot positions in the final matrix in the original matrix and list the pivot columns. Okay. We'll try 4. So what we have, let's see, number 4, we have is 1, 3, 5, 7. And that's 3, 5, 7, 9, and 5, 7, 9, 1. So what we want to do is get everything in the leftmost column to be zeros, right? So I'll just write the first row. Now if we think about it, I can, in this next step, I can get rid of the 3 in row 2 and the 5 in row 3 all at once, can I? Just by multiplying. So what I'm going to do to get rid of the 3 in row 2 is I'm going to multiply row 1 by minus 3 and add it. So this becomes 0. 1 by minus 3, it's 3 times 3, there's a minus 9, 5, so that's a minus 4. Minus 3 times 5 is 15, minus 15, and 7 is a minus 8. Minus 3 times 7 is a minus 21, so that'd be minus 12. Did I do that one right? And I'm going to do the next row down, because I can do it at the same time, right? So I'm going to do minus 5 times the top row and bring it down. So that'll make this one 0. Minus 5 times 3 is a minus 15, plus 7 is a minus 8. Minus 5 times 5 is 25, plus 9 is a minus 16. Minus 5 times 35 times 7 is 35, plus 1 is minus 34. Is that what everybody got? I can't add, subtract, multiply, or divide in my head, so I have a little trouble with this. Now, we got two choices. We're looking at row 2. We could get that first element in row 2 to be a 1 by dividing that row by minus 4. That'd be one option. But we want to get that minus A in column 2, that minus 8, to be 0. I'm thinking that I'm going to leave it the way it is and multiply row 2 by 2 and combine it with row 3. Right? Is that everyone good with that? And then what I'm going to do at the same time, I'm going to be working off of the matrix here to do row 3, but I am going to go ahead and divide row 2 by minus 4 so that I get it this way. But now what I'm going to do is I'm going to do this matrix to get the 0. Do you understand what I'm doing? I'm kind of just combining things so I don't have to rewrite the matrix. So I'm going to take the second matrix and eliminate the minus 8 in the third row. So I'm going to take 2 times the second row and combine it with the third row. So 2 times 0 is 0. 2 times minus 4. I got to take a minus 2 times that, right? Minus 2 times a minus 4 is a plus 8. That makes this one go to 0. Minus 2 times a minus 8 is a plus 16. And a minus 2 times 20 times 12 is 24 plus, and that was, what was that number was, what was this number here, 39? 34. So it's plus 24 minus 34, that's a minus 10. Okay. Now I can tell you right now that that's inconsistent, because that bottom row, you're not going to get a solution here. We can do the rest of the problem and get zeros above it, but we got an inconsistent set of equations right now. Because I want to show you why it is. This was supposed to be a 7, right? Right at this point, this equation is, if you say that this is the x1 row, this is x2, this is x3, and this is a b, the first row you have x1 plus 3x2 plus 5x3 equals 7. The second row, you don't have an x1, right? You got an x2 plus 2x3 equals 3. And the last one, you have 0x1, 0x2, 0x3. So on this side of the equation, you got 0. On this side, you got minus 10. See what it is? When that row is zeros, and in the right-hand side row, you have a number, you have an inconsistent set of equations. Does that make sense? You see why? That's why it is. You have no solution to this problem. Now, I can't even get this thing in reduced echelon form, because, you know, I could do this to this matrix. I could do 1, 3, 5, 7, 0, 1, 2, 3, and 0, 0, 0, and I could divide this row by minus 10 and get this to 1. But you see, above, I don't have, down on the diagonal, I don't have a 1 right down here, right there. And reduced echelon would say that this one would, and this one would have to be zeros. I got no way to do it. I can't make the 2 and the 5 zeros, right? And that would, I could make that thing 0 with this, but I can't get the reduced echelon form. Does that make sense? And it's all because that last row has a 0 on all of the variables, and in the B part, it has a number. Now, if that last row were all zeros, then you would have a parametric solution. You would have a free x3 that could be anything, and then the rest of them could be solved, but they would all be in terms of that free one. Does that make sense? Anytime you have a row that your last column to the right has got a number in it and zeros every place else, you'll have an inconsistent equation. And I hope this thing makes sense why it is. You see, I mean, it's just logical why it is. Just tell me. Not to say I didn't have them where I came from, but They always confuse me. So, oh, so we can't really describe the pivot rows and pivot columns because we don't really have pivots in this darn thing. Because the reduced echelon form didn't exist. Okay. In the problems 7 through 14, it says find the general solutions of the systems whose augmented matrices are given. For what it, see, pick one. Be nice to pick one. Unfortunately, I didn't do this one, but I'm going to do 12. 12. See what happens. So we have this matrix. 1 minus 7, 0, 6, 5. And I got this 0, 0. Minus 2, minus 3, minus 1, 7. Now the first thing I'm going to do with this is what I'm thinking about doing isn't really going to help much. I was thinking about taking row 2 and putting it down in row 3. So then I'd have a 1 in the third column. But you see, if I try to eliminate this value, get it to 0, what's going to happen to this value? It's going to be 0 too. So if switching those rows would be kind of worthless, useless, because I'd have those two anyway. So let's just go ahead, take row 1, add it to row 3 to get rid of that minus 1, and we will get rid of the 7 at the same time. Now, you see, what did I do? I thought 1 step ahead, then I thought 2 steps ahead, and then I was thinking 3 steps ahead, right? To try and figure out if something I did a certain path, and I think that what I was thinking was probably right. So then I eliminated the idea of switching this row down 1. It could have been good if that third row would have made a 1 in the second column, but it didn't when you combine row 1 with row 3, and we're going to get a 0, but then we're going to get a 0 here. This is going to still stay minus 4. This is going to be 8. And then we're going to have 12. Did I do all my adding right? Okay. Now notice that I got 1 in the first column, a 1 in the third column, and I got everything to the right. I'm still good. So what I want to do with this is I want to do what? Eliminate that minus 4. Would it be beneficial before I eliminated minus 4 to divide minus 4 into that last row? If I did it, then I wouldn't have to multiply the second row by 4, right? I could multiply it by 1 and just bring it down. Does that create any other problems? I think, do you see what I see? I think we're going to get an inconsistent equation. Maybe, maybe not. No, maybe we won't. Because no, we would, because we multiplied 4 times the second row, brought it down, then 4 times the -2 and brought it down, we'd have -8, we'd have zeros there, right? But then the last row, the last row would eliminate the 12, we'd have zeros across the bottom. We wouldn't have, we'd have parametric. So, rather than waste the time and divide the last row by -4, go ahead and subtract it, right? So after thinking about it, going through, we can say, well, you know, this is the way we're going to proceed with this problem. Leave this row. And then I'm going to multiply row 2 by 4, combine it with row 3. When I do that, that makes this 0, that makes this 0, and that makes this 0. Now that bottom row has all zeros, we got parametric equation. What we have, if we write this out with x1, x2, x3, x4, and a b, we have the equation x1 minus 7x2 plus 6x4 equals 5. And then we got x3 minus 2x4 equals -3. And we got x2 and x4 are floaters, right? So if we put values in for any values in for x2 and x4, we can solve it. Because see this, the reason is this is our pivot row, pivot column, pivot row, this is pivot, right? That means those values have to be fixed. But the x2 and x4 are free. It'll have a solution because that bottom row is not, you know, it's saying 0 equals 0. And that's a true statement. It just says that there's multiple solutions. And the multiple solutions are going to be in that thing. That makes sense? So the pivot, and if you're talking about where's the pivot in the final one, where's the pivot in the initial, they're still in the same position. This one and this one were the pivots, right? In the original equation. Because it's the same row and same column. Because I didn't move if I'd have moved any of those equations around and then I had to change the pivot, then it would have changed the pivot in the first. Does that make sense? Is that good? Do we need to do anything else there? All right, the next group of problems, 15 and 16. It says, use the notation in example 1. Okay. Use the notation in example 1 for matrices in echelon form. Suppose each matrix represents the augmented matrix for a system of linear equations, and in each case determine if the system is consistent If a system is consistent, determine if the solution is unique. So I'll look at 16. Is that system consistent? It's consistent, but the only thing is it has many solutions, don't it? See that bottom row is all zeros. So it's going to be a parametric set of solutions. Because you're going to have x1, supposedly there's ones down there. So you're going to have x1 plus something, x2 equals something, and then you're going to have x2 is equal something, but you don't have an x3. So it's free. x3 would be free to be whatever you want to be, and then you could, whatever you assign to 3, you get a value for x1 and x2. Make sense? So it's consistent, any solutions. How about B? Would you have a free variable there? That x2 would be free, wouldn't it? You'd have specific values for x1 and x2, but when you wouldn't have anything for x3. So you could eliminate x3. You could get zeros above that third column, third row square, right? You could get zeros above the second row, third column. I said that wrong. It's the fourth column, third row. You could get zeros above that. You could get zeros above the third column, second row, but you couldn't get that zero in that first column, second column, or first row, second column. So that would make x2 a free, and you could actually get values for it. You'd have a parametric set of equation. All right. 17 and 18 says determine the values of H such that the matrix is the augmented matrix of a consistent linear system. So I'm going to do 18. Yes. 18. One. Now, the first thing I'd want to do is I want to get it in echelon form, right? So what would I have to do? Multiply the first row times -5 and add it to the second. So I'm at 1 minus 3, 2. First row times -5 combined with the second would give me a 0 there. First row times a -5 would make that a plus 15 and combine it with H plus 15. First row times a -5 is a minus 10, combine it with a -7, minus 17. Is this a -2 out here?
Yeah.
Okay. So then that'd be a plus, okay. Thank you. So that'd be plus 10 minus 5 is a plus 3. Now then, let's look at this thing. And it says 18. It says, determine the values of H such that the matrix is an augmented matrix of a consistent linear system. Well, now, this particular thing right here could not be what? For it to have to be consistent. What would it be if it were inconsistent? 0, right? So what it can't be is what we just were talking about, right? Down in the office. The H plus 15 cannot equal 0. So H cannot equal negative 15. If it were equal to a negative 15, it would be an inconsistent set of equations, right? But if it's equal to anything other than 15, anything, it's going to be consistent, and you're going to have a solution, right? Does that make sense? Because see, if it's 0, then you got 0, 0, 3, and what have you got? You got that incorrect statement where you have 0 equals 3, right? When you write it out. Makes sense, don't it? Okay. All right, so 20, I'm going to do 20, but it says, in exercise 19 to 20, choose H and K such that the system has, number 1, no solution, number 2, a unique solution, and number 3, many solutions. Now, I just want to make a comment on this one we're just looking at. If H is not equal to 15, and if it's equal to anything being you will assign a number and it will have that number, what will happen? It will have a unique solution, right? It will be unique. So, this is a comment on this one. So 20. So it's x1 plus 3x2 equals 2, and 3x1 plus hx2 equals k. So maybe the best way to do this is write it in augmented matrix form, right? So in augmented matrix, we'd have what? 1, 3, 2, 3, h, k. Correct? Now the first thing we'd want to do is eliminate the 3. So then we would go 1, 3, 2, and then we're going to multiply the first row by negative 3 and combine it, right? So that makes us 0. Negative 3 times a minus 3 is a minus 9. So this is h minus 9. And then a negative 3 times 2 is a minus 6. It's k minus 6. Now, let's look at our question here, see whether maybe we can answer it at this point. For this to have no solution at this point, could we do something with, what would you say? No solution if what occurs? Okay, if h minus 9 equals 0. So h equals 9, no matter what anything else is. But the only thing is we'd have to, what would other thing have to be for no solution? k minus 6 could not equal 0, right? So k could not equal 6. No solution. H would have to be 9, k would have to be not equal to 6. So we got no solution. So B says a unique solution. Well, unique. What would have to happen? H minus 9 would have to equal what? So H would have to equal 8. And what about K minus 6? What's that? Yeah, you're right, 10. I can't. Thank you. You have to be careful because I can't add. Sometimes I don't know my operations. Can't. Is there anything about that K minus 6 that we'd have to stipulate? It could equal 0, it could equal any number, couldn't it? So K could equal, I guess, any real number, element of the reals. Now then, many solutions. Let's see. Now then, what would have to happen? Okay, H minus 9 would have to equal 0, right? So H would have to equal 10. 9. I can't do this. 9. And then K minus 6 would have to equal what? 0. So K would have to equal 6. So you'd have to have this. Now you'd have many solutions. All right? Pretty easy, right? Once you kind of get the idea of what it's. Okay. So it's at 1:45, right? That's it. So I'm going to give you about 20 minutes to do the quiz. That would mean in 5 minutes you got to start it, right? Is that right? I'm calculating right. Now, the next section, they're going to talk about R2 space. Now in R2 space, we're talking about graphing things in 2 dimensions. And you're going to have vectors. You're going to have something called vectors. And if you look at, just for example, that thing where it says, and I can't, can I get, I don't think I can get broad things. Right, I can't make, you just have to go with me. This U, it's always a big wide line U. And that's a vector. And notice they're saying 3 minus 1. So actually what that is, that's an X is 3 minus 1. So it's It's actually that point, and then that ray. So this is the vector. Yeah. That right there. So that's the way you represent it. It's actually a point out there, but it'll be vectors. So that's what they're talking about, and it's in R2. Well, now if you're in R3, then you're in that three-dimensional space. So then each vector is going to be a three like they're talking about R3 on page 27. Let's see whether we can do that A vector, which is 2, 3, 4. So it's going to be, and then they call it X1, X2, X3. So I'm going to put X1, X2, and X3. A lot of times to the right is X, to the left on the bottom is Y, and then Z is vertical. Maybe it depends on however you do it, but the only thing is this thing is going to be X1 is 2, so I'm going to come out here to 2. Then I'm going to go X2 is 3, so I'm going to go up 3, and then 4, so I'm going to come back down this way. 1, 2, 3, 4. Point right up there, and then what it is, it's a vector that comes from here it comes from that point right there out to here. It'd been better if I'd had it someplace else. See, if you had the vector B, and you make it, you'd make that one, we'd make that one 5, 3, 4. No, then we'd actually go 5. Out here, I'm still not getting. I should do something, get myself out. If I set this one out at 5. I'm just trying to get it so that you can see. That would be a point right here. And the vector would be the point from here out to here. Now, if you have R4, visualizing that thing is ridiculous, right? Then you got to have a fourth dimension. Where's it at? Now this is just space. That's like this room, right? Pick a corner, make it X, Y. You know, X3, X1, X2. Usually you'd go X, Y, and then Z on the height. And then you'd run then you'd come out to a point, and it'd be that line up to that point. All right. Oh,
Now there's two sheets to this thing because when I went to do it, I went to have it on front back. I hope this isn't, put your name on both sheets. Try to distribute that around. Hand it around. He's got the second. Did you get him one? No, six. That's an idea. Did you get the first one?
Yes.
Okay, you should have one that says, and put your names on both of them. You should have problem number one, problem number two.